Hi, my name is Paul, and today here on Master the NEC, we're going to talk about some significant changes to the 2014 National Electrical Code. And hopefully you have your 2014 code book handy, whether that be the handbook, or whether it's the paperback book, or whether it's the analysis of change that's put out by IAEI, International Association of Electrical Inspectors. Great organization. Everybody should join, support that association, as well as NFPA. All people that are in the electrical industry should be supporting NFPA as well. Anyway, so let's talk about the changes. So the NFPA says that there was over 3,745 proposals that were submitted for the 2014 process. And after that happened, then you have the public comment stage, and they say an additional 1,625 public comments were submitted for the modifications to whatever those public proposals were, or whatever the reaction to those comments to those proposals. So that's quite a bit, and it's quite a lot of work for code making panel members to look over, and of course there's different people lobbying for specific interests and what have you, and experts who can weigh in during this process of developing this standard. And so during that standard, there were a lot of code-wide changes that took place, and of course a lot of proposals. Many were rejected, but many made it into the code. So we're going to talk about some of the changes that took place, and it's probably going to be a multi-part series. And we're not going to go too in-depth because we like to cover as many changes as we can, but we're going to give you as much information as we can and to try to help you out a little bit. So let's just jump right on in. The first thing we want to talk about is a code-wide change, and that was field-applied hazard markings. And this is found in 110.21b. This expanded. And it was added to basically allow for the application of expanding the use of a field-applied hazard marking. So it says in the NEC, and if you go to 110.21b, you'll see that A was already there. That's manufacturer's markings that the manufacturer is going to put on there. All right, but let me look at B. It's field-applied hazard markings. It says where caution, warning, or danger signs or labels are required by this code, that's the NEC, the labels shall meet the following requirements. It says 1, the marking shall adequately warn of a hazard using effective words. That might be, the words might be caution, warning, or danger, depending on the application. Or it says and or colors, so I can have colors associated with that as well, or symbols, so I can have specific types of symbols that are associated whether or not it's a situation of caution, warning, or danger. Now, where did all that come from? As you'll see, there's an informational note, and as we all know, informational notes are simply guidelines. I mean, they give you some guidance, not guidelines, I should say. They give you some information. That's all they are. They're informational. They're not enforceable, but it kind of gives you that information you need to know. Where did they come up with this from, or where can I get more information about this? Well, that's going to send you to the ANSI Z535.4, which is the Product Safety Signs and Labels guidelines. And in there, it's going to provide guidelines for the font size, recommendations for colors for those different conditions, wording, actually location for the placement of the labels, and all those type of things are going to be there. So it gives us some guidance when we're applying those field apply, whether it's photovoltaic applications, and we have to label. There's a lot of labeling that goes on under 690. So all of these guidance helps give you somewhere to go, which is the ANSI, to give you some guidance on the labeling requirements. But the NEC is going to tell you that those issues of field-applied hazard markings have to be done, and they shall meet the following requirements, and that's what you've got here. Next, it also says the labels shall be permanently affixed to the equipment or wiring method and shall not be handwritten. Okay, so this is you don't want to have to worry about reading somebody's handwriting. You don't want to worry about any of that. I mean, it has to be produced, and I'm pretty sure that the next one's going to be that it has to hold up for the durability of the environment that it's placed. And of course, that is what item number 3 is. It's going to say the label shall be a sufficient durability to withstand the environment that's involved. If it's outdoors, It's got to be able to hold up to the outdoor environments. If it's in indoors and it's an area where it's elevated heat, it's got to be able to hold up. You don't want a sticky back that when it gets so hot that it just peels off. I mean, all those things, the inspector's got to make a determination that it's for that environment. So keep that in mind. Again, you're going to get some guidance out of the ANSI Z535.4 standard, which recommends you, if you can get a hold of it. It might be free. I don't know. I have a copy. I don't know where I got it. I didn't steal it. I got it. It's official. But I've often been accused of that once in my life directly by NFPA, but that's never been true. But what have you? It's available. Just go on and do a search on the internet and you might be able to find a copy. All right, so let's go on to the next one. So next one we would look at, which is a code-wide change, is a lockable disconnecting means. So a new section was 110.25 was added to deliver a one-stop kind of shop location for the consistent requirements for lockable disconnection means. Okay, so we have this one-stop shop for it now. So if you go in your code and you look for the 110.25, you'll see it's all grayed out in the 2014 edition, and it says lockable disconnection means. Now, here's what the verbiage says. It says where a disconnection mean is required to be locked open elsewhere in this code. So again, there's places in 422, there's places in 430 that might have a requirement that says that the disconnect mean has to be, lockable in the open position, okay, and what have you, somewhere else in the NEC. Then what's going to happen is, here's where it's going to reference now to give that guidance for that. And it says, where the disconnect mean is required to be in a lockable open elsewhere in this code, it shall be capable of being locked in the open position. The provision for locking shall remain in place with or without the lock installed. Okay, so that was previously, it was held in things like 422 for appliance applications, or it was held up in 430 for motor applications. Now it's going to make specific references where it's required to be lockable in the open position. It's going to reference you back to 110.25, which is going to give you these rules. And of course, there's an exception that it deals with a cord and plug connected locking provisions. Okay, they're not required to stay in place because generally they go on top of the cord plug or cord cap, and you can lock them. But they're not required to stay in place when the lock comes off because they obviously are going to pull right off. Okay, there's no way to keep them in place. So anyway, you have an exception for that for the cord and plug connected type. But this is just kind of bringing it all in one place, in 110, because 110 is labeled requirements for electrical installations, so that's just the right place for it to be. Okay. All right, so next one we're going to look at is requirements for DC system integration. Hey, you all know that over the years, photovoltaic applications have expanded. Wind generation has expanded. Microgrid applications have expanded. All of those applications where you're dealing with potentially DC voltage or DC systems in general, 480 for battery applications, all of those type of places have changed in NEC. They've evolved. So a lot of dedication has been given to those by the code-making panels that oversee that. And so with that change becomes a lot more requirements that have to be incorporated as technology expands. And so there's a lot of energy that's wasted converting AC to DC. So some applications where you can save on a lot of that conversion and simply distribute DC through some kind of building like we're seeing with that 393 application, then you'll find yourself to realize that the DC is emerging and we need some guidelines for it, whether it's now requiring that under a certain size the conductors have to be red and black, or they have to have a positive and negative marking on it depending on what size they are. All those type of things have changed within the NEC, and so we needed some more guidance. So throughout the NEC, you're going to see a lot more DC system integrated throughout the NEC in those changes. So bear in mind for that. Next thing we're going to have is a code changes. How many of you really got confused when you looked at switchgear and you looked at metal enclosed power switchgear, metal clad switchgear, low voltage power circuit breaker switchgear? It really got confusing when reality is the switchgear requirements needed to cover all of them, or the term switchgear needed to cover all of these switchgear applications when it talks about it throughout the NEC. So the term switchgear has been used to make it now all-inclusive for all types of switch gears, wherever it is, like in 480, where it talks about panel boards, now switch gears, and switchboards. Okay, or switchboards. So this kind of an all-encompassing thing now when it encompasses all three of those types of switch gears under the general term switch gear. So that is throughout the code, anywhere in there that had those individual type of switch gears called out. Now it just simply refers to switch gear. Might help a designer if they got confused in the different requirements. Okay, but that's the change. The next change that took place is just a reminder that there were a lot of changes. So if you're new to the 14, you're coming into the industry, or you've only been in it for maybe 1 or 2 cycles, and when you think you know the definitions pretty good, more definitions have been added to 100 that were pulled out of many of the articles that were in the .2 section, which were specific to that article. But now they're being used in more than one article, so this manual, the NEC style manual, is going to require that those definitions of those terms now be included in Article 100 because they're being used in more locations. A good example of that would be in arc fault circuit interrupters. For years it was held under .2, the definition just in 210. Article 210, and of course now it's expanded into 550, it's expanded into other areas, mobile homes, other applications where you're going to have the AFCI requirements. So now the definition gets moved to Article 100 because it's used in more than one location. And under the 2014 edition, you're actually going to see arc fault circuit interrupter, which actually was moved, I believe, back in 2011. Not in the 14, but now that's just an example I'm giving you. But now that's all the way back in Article 100. That's where you see that. So anywhere in the code that a term was used more than once, in more articles than one, in other words, now it gets relocated over into Article 100, kind of a good collection place for definitions. In fact, that's what Article 100 is, definitions. So it makes sense. So kind of keep an eye out on that. Some of the terms you might be looking for out there that you're familiar with finding under the .2, you might realize now they've expanded to more usage areas. So you're like, oh my God, where'd it go? Well, it just got moved to 100, so now you know. Another code-wise change that affects more the manufacturers of electrical equipment like switch gear, panel boards, enclosures, circuit breakers, all that kind of thing, was the increase from 600 volt to 1000 volt threshold. You all might be familiar with that by now. But that was, the talk about it's been for a couple years now, or if longer. The task group was put together, and they submitted their proposals to the code-making panels. There was a lot of proposals, over 100, I believe, that came in on that. And they looked at it, and so generally all of the code-making panels, except for Article 100 and 110, which is on Code Making Panel 1, they didn't see the need to change it because theirs either dealt with 600 volt or less or over 600, so it really didn't affect them. But a lot of the other articles did change and move that threshold from 600 volt to 1000. Now that's a big deal for the equipment industry. Not so much for the wire and cable industry, because we already made products, for example, for photovoltaic applications where they were 1000 kV or 1 kV and 2 kV applications, and that's more like a thermoset type of insulation, like an XHHW-2, if you will. Whereas the thermoplastic type things, like the THHNs and THWN-2, that insulation is much thinner than you would with a thermoset, and so it wouldn't meet the 1000, but it clearly meets the 600 volts. So in the wire and cable industry, most of our circuits for general use are under 600 volt, whether it's a 120 208, a 120 240, a 277 480, those type of applications. Then the wire that's marked 600 volts, you're still free to use. It's fine. It doesn't change anything. But there are other applications where you're going to have voltages that are over 600 volts that were kind of in that limbo land, if you will. And that was some of the larger photovoltaic systems, or even some wind generation systems that really worked at voltages between 600 volts and 1000, or I should say 601 volts and 1000, because that area really didn't give us any guidance, because we were dealing with under 600 volts or 600 volts or less and 1000 or more, so we had that limbo land. And so that's what we were trying to pick up with this change. So if you have systems that need to have something that has a voltage higher than 600 volts, but under 1,000 volts or 1,000 volts or under, then you need to find components that are listed that have been evaluated for that use. And that is really key in photovoltaic systems, wind generation type systems. So that's the kind of thing. Some hold on there, voltage, daggone it, variable speed drive applications, which might have an application where it goes over 600 volts. Just things like that. You needed products that could meet that. So that really affects the product aspect of it more than you would, wire and cable industry. Just so you know that generally thermoplastic type products like THHN, THWN-2, what have you, and all that, they're going to fall on the 600 volt and less side. Unless you increase the insulation. If you increase the insulation, it probably would pass without a problem under UL testing, whether it's a UL 83. But what happens is it's going to change all of the values that we currently have within the NEC for raceway fills and things like that. So it would be a big undertaking, right? Whereas this is already taken into account when you're dealing with thermoset type products like XHHW and XHHW-2 and what have you. So that's not a big change because that product doesn't have any issues passing it. So that's why you're going to see this slow transition. But when it comes to wire and cable, again, most of the applications for building wiring is 600 volts or less. So you don't really have a need or a worry as long as you're within that realm of product. But that's why we make photovoltaics that are 1,000 volts or 2,000 volt rated for those needs. Okay, that's enough of that. All right, so also in the 2014, we now have 4 new articles. I know I can hear the cheers going on now. We have 4 new articles that we can talk about, and we're going to look at each one of them. Well, the first one we're going to look at, and you know what we're going to do? We're going to read the scope of each one so we know exactly what the scope these are dealing with. And again, that's a little hint to you. If you ever are lost in that code limbo land, you don't know whether or not the code applies to this application, always go and read the scope of that article and try to define it from there. Because sometimes you could be thinking that this article applies, or this section within an article, and you read the scope and you realize, whoa, it didn't apply at all. And boy, that's kind of waste a lot of time, right? And time is precious. So let's look at the first one. We're looking at 393. Now let's get your code books out and let's go to 393. It is new for the 2014 NEC. And I'm kind of excited about this because this is another avenue where we're introducing DC power through the ceiling grid support system members. It doesn't energize the whole grid, just the specific members of the grid in this type of product. And so let's read the scope of this thing. It's an article covers the installation of low voltage suspended ceiling power distribution systems. All right, so that's what it is, and it powers the ceiling bus rail, independent ones that are part of the installation. So manufacturers produce this type of grid, and they'll make these energized buses, if you will, rails, that actually interlock into the grid, and you take over the low voltage to that grid, and it snaps in, and that grid is energized. So then you have other systems that allow the wiring to come over and snap into that grid or make connection to that grid in order to power that low voltage lighting through that power grid. And then you can loop grids together, and this all has to be done. Now the debate is who installs it. The electrician have to install it, or does it have to be installed by the manufacturer because it's a specific manufactured product and they're the experts at it? Your jurisdiction will have to make that call. Electricians might not be aware of it, of how to do it as much as the technician who actually is an expert at it, who's factory trained. So, you got to look at it from that aspect of it, and your jurisdiction is going to make those specific calls. But when I look at Article 392, I look at it and see that it's fairly short, but it gives a lot of information on the construction of it, how to make the connections to the grid bus, the grid rail, and all that type of thing. Disconnection means for this Class 2 power, because again, once it switches over and starts going out to this grid, then we're looking at Class 2 powers, and of course you're going to have Class 2 power supplies and all that kind of stuff. So there's a lot of guidance here, so if you're into that type of system, then here's what we needed in the NEC, because that system is going to allow for the providing of low voltage AV devices, low voltage luminaire applications, electrical equipment that is actually low voltage. All could be powered, even some utilization equipment, different sensors for certain applications, can all be powered from this powered rail, this low voltage rail. And this is pretty neat. Now again, don't think they're powering the entire drop ceiling. Okay, the grid system that supports the drop ceiling panels. It's specific rails that are in there. Now, I don't know how many number of rails. I guess that depends on the system. But that's what it is. So this is emerging. It was coming out well prior to the 2014 NEC, but without any specific guidelines on what to deal with, how to deal with it, then we needed something in place. So this is great. So those products are coming. Again, like we talked about, it's emerging low voltage technologies emerging through the buildings. It's energy efficient. And so, hey, it just seems like a good thing to me. So kind of get your head around this, because this is some changes, and now we've got some guidelines for it. Okay, the next one we're looking at is called Article 646, and that's a modular data centers. Now, the first thing I'm going to tell you is get your code books out, like always, and you need to go to 646. And I'm going to do it as well, so that I don't, try to, I found as I got older, I just try not to quote things from memory anymore. It's just easier to go to it and read it, because I get in trouble, because I can't remember everything like I used to remember everything. All right, so let's look at it here. Article 646 says modular data centers. All right. Okay, 646 covers modular data centers, and then let's look at the scope real quick. It says this article covers modular data centers. Okay, I kind of think we got the gist of that. So what is a modular data center? Well, let's look down here under the definition. Again, it's .2 under definitions. Again, we talked about it earlier. The only area that modular data centers would be used is in 646, so obviously the definition is going to be under .2, but at some point, if this definition was used somewhere else in the NEC, then it would be in 2 or more articles, then obviously this definition would move to Article 100. That's how it works. But it only pertains to modular data centers, so let's read it. It says a prefabricated unit rated 600 volts or less, okay, consisting of an outer enclosure housing multiple racks or cabinets of information technology equipment, or ITE, example would be servers, if you will, and various support equipment, that'd be the servers and the power supplies and all that kind of stuff, such as electrical services, distribution equipment, HVAC system, and the like, that are all associated with that modular data center. So it's kind of a package deal, prefabbed application. Now, the one thing I'll tell you right off is we didn't have any guidance for this, because you really couldn't use 645 for that application, which is information technology equipment. But many of the sections within 645 are going to be referenced from modular data centers, because this is dealing with the modular data center, but the equipment in it still needs guidance from 645. But it is different. It is a modular type of data center. And when you go looking at 646, you're going to see there's a lot of requirements in here for the application. For the service equipment that supplies the modular data center, it's going to tell you that you got to follow the requirements of Article 230. It's going to do that, obviously. It's going to have its own disconnection mean requirements, and it's going to reference a lot of the MDC, or the modular data center requirements, that are the same as the disconnect requirements in 645.10. So you're going to see that is very similar. It's going to talk about nameplate data information on these modular systems, which is real important. You need to know the loads, the duty cycles, if anything that's involved in the equipment, the full load currents, when you got to calculate how you're going to supply power to these things. So you got nameplates that are all associated with it. Now we have some guidance. The branch circuits and feeders that are going to be fed to the different pieces of equipment. All of that is given guidance in here now under 646.7. And that's when anticipating what it says here. It says short circuit current ratings, whether it's service equipment or branch circuits and feeders. So there's a lot of information here. The wiring compartments, what wiring you can use, what wiring method you can use, what's permitted, what's not permitted. All of that's going to be in here. So now you have some guidance for those modular type of data centers. Okay, so that's basically wasn't there before. They were existed, but you didn't know how to deal with them. And you really couldn't apply 645 to them, even though you tried. But now it's in there, and so we have some guidance. And hey, that's important. Anytime you can get some guidance on something so that you're not just out there when you're dealing with inspectors who have the best interests at heart, but without guidance, we're kind of technical people. You know, we want to see something written down. We want to see some kind of standard for it, some kind of guidance. We don't like to just willy-nilly or go off the hip type of thing. So that gives us some guidance, and that's a good thing. The next article that gets added to this edition of the NEC is Article 728. Now, 728 is a welcome addition to the NEC, and that is called fire-resistive cables. Now, let me read you the scope, and then I'll read you what a fire-resistive cable system is, so you kind of get an understanding. But we didn't have any direction here. Manufacturers could make this product. We didn't really know its use or guidelines, and if the code called for some kind of fire-resistive cable system, what is it? You know, if it was an emergency application system under Article 700, we just didn't know. So now it says this article covers the installation of fire-resistive cables, fire-resistive conductors, and other system components used for the survivability. And that would be also, you know what, the COPS systems in 708 have this issue where they got to have this survivability. Of critical circuits to ensure continued operation during a specific time under a fire condition as required in this code. So other areas of the code are going to give mention to the usability of a fire-resistive cable system. And so without simply saying what is that and trying to get information from a manufacturer, now we got a place to go. Now, granted, 728 is going to do a lot of referring back to the manufacturer specifications, but at least it is a growing area for expanded information when it comes to these fire-resistant cable type systems, whether it's the fire-resistive type of cable or a conductor, or whether or not it's a full-blown cable system. Now, let's read it. It says, what is, and again, there's a definition here in dot 2 because it only applies to fire-resistive cable systems. It says, a cable and components used to ensure survivability of critical circuits for a specified time under a fire condition. And it says, what's this? Look at some general. I'm just going to read you some general stuff here. It says general, 728.4 general. It says fire-resistive cables, fire-resistive conductors, again, it covers that as well, and components used shall be tested and listed as a complete system, shall be designated for use in a specific fire-rated system. And again, we get that a lot when we're talking about emergency-type systems, COP systems, and what have you, when it requires to have that sustainability of the system. It says, it shall be designated for use in a specific fire-rated system and shall not be interchangeable between systems. Okay, so it's a specific system that's evaluated as part of that system. It's not a piecemeal type system where you can take something from this and something from that. They're not interchangeable between the systems. It's specifically listed system. It says fire-resistant cables, conductors, and components shall be approved. Okay, so now it's required to be tested and listed. But at the end of the day, it says that the fire-resistive cables, conductors, and components shall be approved. And of course, what does that mean? Approved means that after all is said and done, the authority having jurisdiction has to approve it. And what's he going to need to approve that? He's going to need the information from the manufacturer in accordance with, and also the information is in 728 together. So the manufacturer is going to have to show you that this system is a system, that it's evaluated together. All right, when you put this with this is what the system is. Or if it's the individual conductors installed in this type of raceway, it's a system. Or if it's this type of cable with some kind of outer jacket or outer protection with the inner conductors, that's a system. And that's what the manufacturer will have to provide to the authority having jurisdiction. Who has the power to approve? Okay, nobody else can do it but the AHJ. Now, just so you know, when it gets into mounting them and supporting these cables or these conductors, or whether they're used in cable trays or boxes and supports vertically or splices, all you're going to see in here is a bunch of referrals back to the manufacturer's installation instructions. Again, they're the experts. We just needed somewhere to give guidance, and this is going to expand, obviously. But the manufacturer has all this information because this is specialty products. There's part of a listing and an evaluation or a testing that's involved. So they're going to document all this, and they're going to have this literature available, trust me. So that is what the inspector is going to want to have. Plus, they're going to give the guidance. They make their product, and they're going to tell you how often to support it, how often to secure it, and what have you. And you just have to follow the manufacturer's recommendations. In fact, you know what? I'm going to take that back. I'm not even going to call it a recommendation. It's the manufacturer's instructions that have to be followed. 110.3b. Boom, boom, boom. So it's not really a recommendation. So if I could go back and erase that, I'd erase it. But nope, this is a live show. I'm recording it live. You might be listening to a recording of it. But hey, we're going to go with it. All right. So yeah, splices have to be done in accordance with the manufacturer's installation instructions. So you got to follow all that. Also, the cables or the conductors have a surface marking of the suffix FRR. That's his fire resistive rating, along with the circuit integrity duration in hours. In other words, if it's 2 hours, 1 hour, 3 hours, whatever. And it's got to be a part of the identifier. So that's all the requirements for labeling it. And of course, the manufacturers know this, so they're going to be required to do that. So there's no questions here on how to do it. Okay? All right. Let's move on. Spend too much time with that either. All right. So now there's another new article to the 2014. Man, there's only 4, so relax. But I know it seems like it's taken forever. But there's 4. Now, the 4th one is a real important one to me. And that is, when I worked with NEMA, we were very involved in dealing with the Energy Code, International Energy Code, and the International Green Code. Not my favorite documents. It's no secret that they aren't my favorite documents, but they are very important documents because the energy consumption and our needs continue to go up with electronics that consume power and all of the advances in technology that consume power. What we're doing is making a real effort to reduce some of the load on these equipment that produces the after effect of what we need, like the lighting now with LEDs and CFLs and all that type of thing. But there's still a huge demand for more current. And so energy management is an important thing that incorporates a lot of buildings, whether they're LEED design buildings or just government buildings who are required to mandate energy efficiency and energy management. So with all that innovation that's coming in, we need to make sure that those systems do not interfere with things that are critical or essential to maintaining, that have to be run. In other words, those things that aren't subject to being turned off, the reduced in power, like load shedding and things like that are necessary to take place, or emergency loads or healthcare facility critical or life safety aspects. So we have to have some kind of guidelines for that. So in the NEC, we have a new article, and that's Article 750. And the scope of this article applies to the installation and operation of energy management systems. Now, there's some definitions here that are only going to apply to energy management systems. Okay, so keep that in mind. But the key thing is, what is an energy management system? We can talk about it. People can say this or that about it, but what is it? Basically, your definition here is a system consisting of any of the following: a monitor or monitors, communications equipment, a controller, a timer, or other devices that monitors and or controls an electrical load or a power production or storage source. Whether it's a storage source, whether it be batteries, whether it be fuel cell applications, whether it be photovoltaic applications, whether it be system monitoring throughout a building, timing different things like the lighting loads, all these type of things kind of are trying to energy management. And basically what it's saying here is all of those things that are within energy management systems have to follow the guidance of 750. Prior to that, you had to worry because sometimes the energy management system might override trying to save energy. It might override something that's essential, like a fire pump or a healthcare facility application, or maybe even some emergency loads or legally required standbys and what have you, or maybe some critical operations of power systems like in COPS or whatever. So we needed some guidance. So that's what 750 does. And more importantly, let's look at a couple in here, because this is a neat one that really set the tone here and say, hey, you can manage the energy of a building in order to meet energy codes, building efficiency, LEED aspects, but there's certain things you have to leave alone. And the first thing we'll look at is 750.20, and that says alternate power sources. It says, an energy management system shall not override any control necessary to ensure continuity of all alternate power sources for the following. So I have alternate power sources for fire pumps, alternate power sources for healthcare facilities, emergency systems, legally required standby systems, and critical operations power systems. Okay, now I can monitor the normal systems in a building. Okay, the fire pump's obviously not on in that time. I can manage any of these. The emergency system's not on during that application. I can manage the general use applications of a building. But when you have an alternate power source that is designed to come on during one of these conditions, the last thing you want is to have a power management system who maybe cuts the power down on certain aspects of a building after, say, 9 o'clock at night, and then have an emergency or a fire pump condition. And we all know the requirements for a fire pump is to run until it burns up. Last thing we want is try to save energy there. So with the alternate power sources, they really can't be controlled by this energy management system. Now, the normal operation of the systems of the building are full game for the management system, but not these alternate power sources. They have to be there. They have to be I don't think, you don't want to mess with them. I always use a real fancy word, and everybody say, wow, Paul used this big fancy word. But I'm not going to use a fancy word, one, because I can't remember it, and two, I would just be made fun of on one of those message boards or anyway. So, okay, so you don't want to mess with that alternate power source, okay? The next thing you want to look at is, let's look at load management. 750.30, it says energy management systems shall be permitted, not required, shall be permitted to monitor and control electrical loads unless restricted in accordance with 750.30A through C. So look, it can monitor, okay, the electrical loads, but there are restrictions. And one of the restrictions is load shedding controls. It says an energy management system shall not override the load shedding controls put in place to ensure the minimum electrical capacity for the following. So when I have load shedding applications that are put in place for fire pumps, emergency systems like generators, legally required standby systems like generators, and in critical operation power systems like maybe generators, if I've got it designed to load shed, then I can't have an energy management system interfere with that load shed process. Maybe I need to shut off some optional loads in order to be able to run emergency systems. Well, I can't have it interfere with any of that. I need to be able to run the emergency systems. So that's what it's taking place. Another good example is disconnection of power. Look at 750.30b. It says, an energy management system shall not be permitted to cause disconnection of power to the following. So an energy management system can't control elevators, escalators, moving walks, stairway lifts, chairs, positive mechanical ventilation for hazardous classified locations. Boy, that would be a no-no to cut that off, wouldn't it? Ventilation used for exhaustion of hazardous gases or reclassified an area. In other words, I have an area that has proper ventilation exchanges and it turns it from maybe a classified to a non-classified only because of that ventilation. Obviously, I can't have it turn off that ventilation, because then it takes an area that was reclassified as a non-classified area due to a certain amount of ventilation or air exchanges, now becomes a hazardous location, and it kind of messes it up. So those are some examples. Circuits that are supplying emergency lighting. You don't want it to interfere with that. Now, if it's a unit type of equipment, which is the battery pack light, and obviously it's not an issue because the batteries that come on. But if it's a generator system or a UPS application or whatnot, you don't want any interference with that. So that's kind of like a no-no. So kind of, there you go. That's kind of the general guidelines you get from Article 750. And it's real important because by not having it and turning off those things under some kind of condition, then you really can put people at risk. So that's a good change. So those are your 4 new articles that are incorporated into the National Electrical Code for the 2014, and they all have their place. Okay, hopefully that gives you some real good in-depth details of what takes place when we're talking about those new articles within the NEC. Okay, now let's look at a few Article 100 definition changes that are significant. First one let's look at would be the definition of the word device. Now that's gone through some changes. Now we know that when we're talking about a device, we're talking about whether it's a simplex receptacle or a single receptacle, duplex receptacle. It doesn't matter whether it's a switch or a locking type receptacle. A fan control, dimmers could be a device, occupancy sensors that have the switching component involved in it, GFCI receptacles, whatever. Those are devices. Okay, that's not the whole list, but that's generally devices. Now, in a device, the definition that came about in the 2014 code, and I'll read you the definition. It is a unit of an electrical system other than a conductor that carries or controls electrical energy as its primary function. And that's what the function it is. Okay, it carries it or controls it, like a fan control, a dimmer controls it, a receptacle, for example, carries it to the point where you can, access it, or a switch controls it. But a lot of times, and the one to think of the most was back in the day when you had the tap rules in 240.21C1, the 10-foot tap rule. One of the allowances is for the 10-foot tap rule was it had to terminate into a device. And people would say, well, a conductor is a device. And it really caused a lot of debate. Now, we've cleared that up because now it says overcurrent device in 240.21C1. But in the day, it was a lot of confusion on what it was. It was also, a conductor, because a conductor itself does carry it, doesn't control it, but it does carry it. So they had to make it real clear that we're talking about a device here. So by adding the words other than a conductor, it makes it real clear what we're talking about. We're talking about, and when we say conductor, we're not necessarily talking about just a wire. It could be a bus bar or whatever. We're talking about something that, we're generally saying that it needs to be a device that actually carries or controls, like switches and receptacles and whatnot like that. Those are devices. Okay, so that's just kind of a general understanding of it. So that changed to remove the fact that a conductor is not to be considered a device. So elsewhere in the code, you don't, the National Electrical Code, you don't have to confuse anything with saying, well, a conductor carries current, so it's got to be a device, and I'm going to use some kind of exploit in the code that permits something to terminate to a device, and you go, well, it's a conductor. Yeah, you know what I'm saying? So that's the deal there. So we have that definition change. Again, there's a change in Article 100 for the definition of device, and that has evolved slowly, and so that's what it is. All right, let's move on to another definition. Let's talk about the intersystem bonding termination. Now, it says intersystem bonding termination is a device that provides a means for connecting intersystem bonding conductors for communication systems to the grounding electrode system. Now, this is a funny one because in North Texas, where I'm at, I'm a member, I'm a part of the North Texas Code Advisory, COAG, or whatever it's called. I don't even remember the name of it. But we all get together, and I was a NEMA rep last time I was there. Now I'm a member of it from Encore. But they had a long debate where they wanted you to allow to take photovoltaics and all that to this inter-system connection point, which is required outside of the building for the communication systems. And they said you could connect to it. And I argued that you can't because it's not evaluated for that. It's evaluated for use in communication systems. And that's it. But they're like, no, you can use it to bond this, and then, I'm like, it's not a communication system, so you can't. Well, it's a convenient location. It's not. It's for communication systems only. So anyway, I fought against it, but, I'm just one person. But anyway, it got in there where they're making a recommendation to use that termination. And again, That's not what it says in the code. It says that that termination is for use with inter-system bonding conductors for communication systems. And that's all it's evaluated for. It might work for something else, but that's not what it's evaluated for. So as an inspector, I'm looking at what it's listed its purpose is. And it is not a purpose for me to be able to use it to connection for a photovoltaic system to connect to it or anything like that. I'm just saying. That's not what it's intended for. So the only permitted to use is for inter-system bonding termination. That's all that it's used for. The previous definition of it permitted bonding conductors to terminate at that inter-system, and I think that's where they were at and what they got caught up in. But of course in Texas we're in the 2014 NEC, and that's what we were evaluating. And so the 2014 changed that by adding that inter-system bonding connection for communication systems. Okay, so the term bonding conductors was revised to inter-system bonding conductors. Again, it's only for use with inter-system bonding terminations. And when we say systems, we're talking about communication systems. But at any rate, that was a change. They added the term inter-system in there under Article 100, under inter-system bonding terminations, to kind of give you the understanding of what we're talking about. So I urge most of the North Texas or anywhere else to totally ignore that allowance. Don't adopt it. It was not to be done. It is not designed for that. Now people say, oh, there's no harm, no foul. Well, man, we could do that everywhere in the NEC, but you can't allow stuff that's not within the scope of the NEC, and you certainly can't condone the use of a product that wasn't evaluated for such of a use. What happens if somebody does it and something happens and a house burns down or something? Who are they going to come back on? The North Texas board? I don't know. They ain't going to come after me because I'm on record saying I didn't think it was a wise decision. Okay, let's move on. All right, so another code change and article change, I should say, in Article 100 is for the term raceway. Now, raceway is listed in here under Article 100 as an enclosed channel of metallic or non-metallic material designed expressly for holding wires, cables, or bus bars with additional functions as permitted in this code. When it says in this code, it means anywhere else in the NEC that might give permission for something to be inside of a raceway. Now, an informational note was added. And that informational note says a raceway is identified within specific articles defined. Now, the definition of a raceway was revised by removing the laundry list of raceways that were in previous editions, or the definition. It had a list of what was considered a raceway. Now, that's all gone now. So inside of each, because that list wasn't complete, you know, there was other ones that could be considered a raceway. And so, or could have met the description of a metallic or non-metallic material designed expressly for holding wires, cables, or bus bars. So there's no sense in having a list. So what they did was instead, under each of the individual articles that deal with a certain product like rigid or intermediate or EMT, it's going to say in that in the actual language of that article, within the scope of it, it's going to say that it's a raceway. So that was added to that. Okay? And again, a new informational note was added to let you know that, hey, if you want to know if it's a raceway, either it meets this definition, but also remember that under each one of those articles, when it is a raceway, it'll say it within the scope that it is a raceway. It'll say it. So that's something that you got to keep in mind. So it's just to kind of get rid of his laundry list, because again, the problem with laundry lists is you got to keep adding to them. You have to keep updating them, and it's much easier to just put it within the scope of the product than it is within the article of the product than it is to try to keep some kind of long laundry list. But you still need a definition in 100 in order to give a general overview of what a raceway is. Okay. All right, so we did that. And so which ones who had their definition changed to include a raceway, just as a general? And let's see if I can remember these right. Now, again, it's all in the .2 because that's going to be under the definition of what that type of raceway is, like PVC, which is rigid polyvinyl chloride conduit, which is PVC. So it's 352.2 is going to have, the definition is going to have the word raceway in it. For NUCC, which is non-metallic underground conduit with the conductors already in it, it's a lot what you see in directional boring, for example, on the side of the road, you know, those type of things. That's 354.2. That's going to have the term raceway in it. 355.2, which is the reinforced thermal setting resin conduit, RTRC, that's going to have the term raceway in it. Liquid tight flexible non-metallic conduit, or much preferably the term LFNC, that's 356, and that's going to be under the .2. And then, of course, busways is a specific type of busway, and it's going to be a raceway, and that's getting added to that under 368.2. And then, of course, you got metal wireways and you got non-metallic wireways, which are now going to be in their language that they are raceways, and that's 376 and 378 respectively. So you have all that in there now. They're going to say it underneath it. Let me give you a good example here. That's not an all-inclusive list. So, because you see that you don't have anything in here for rigid metal conduit. So, just to test that theory, because you know we like to do that here at Master the NEC, we're going to go to rigid metal conduit. And for those that are following along out there who want to check it with us, rigid metal conduit is in Article 344. And if you read 344 and you look under the definition, it says RMC, it says a threadable raceway. Sweet. That makes it easy, right? So if you go and look under, this is a smart change by the NEC. If you go look under, let's look under EMT. So all of you got your code books handy. You want to go to EMT. I was going to tell you which page, but if you just look under 358, you'll see EMT, and it is under 358.2. It says an unthreaded thin wall raceway of circular cross-section design. So there you go. Now we know what's a raceway because it's going to say it's a raceway. We do have a definition of raceway which kind of leads credit to these, but I think it's better to put it actually in the definition of the product. It makes sense to me. Okay, let's move on. Okay, so let's look at another significant change, especially for inspectors, is the Article 100's definition of readily accessible. Now, what is readily accessible? That's capable of being reached quickly for operation, renewal, or inspection without requiring those to whom readily accessible is a requisite, in other words, who has to get there, to actions such as the use of tools, to climb over or remove obstacles, or to resort to portable ladders and so forth. So if I have to use some type of tool to get to something, then that's a problem. It's not considered readily accessible. Okay, now, we do have the applications where something is readily accessible to qualified persons only, and that's in specific applications, and that's why we see the locked covers and what have you. But this is a general rule for readily accessibility. And so if it takes some kind of special tool, which wasn't there before, but if it takes some type, and I tell you what, it doesn't say a special tool. A tool is a screwdriver. If I have to remove 4 screws, for example, to get to a circuit breaker, then I got a problem. It's not readily accessible. Now, if I can open up the cover and there's the breaker, then I can turn it off. It's readily accessible. So that's the type of things that you got to think about. And they added in the 2014 the verbiage to actions such as use of tools. So if I have to have a tool to get into something, then that would be a problem. Okay, so that was a change that was in the 2014 NEC. And let's see here. I want to give you whole ones that are just good changes. Oh, and while we're at it, let's go in and do the switchgear one. So remember we told you that Article 100 switchgear changed throughout. So it used to be in the NEC what you had under 100, for example, is you saw the term metal enclosed power. Okay, and metal enclosed power switchgear. And what's happened is they just simply got rid of the metal enclosed power and it's just switchgear. And it's an assembly completely enclosed on all sides and the top with sheet metal except for ventilation openings and inspection windows where required. And contain primary power circuits for switching, interrupting devices, or both, with buses and connections. That's normally what you'd see in switchgear. The accessibility may include control
The assembly, may include control and auxiliary devices that are associated with that switchgear as part of, like arc fault equipment or whatnot like that. Arc hazard equipment or whatever that's built into it, GFCI applications or whatever's built into it, those accessories or auxiliary devices. Access to the interior of the enclosure is provided by doors, removable covers, or both. Okay, so that's your general requirement. And now they added an informational note in order to give the guidance to the change. It says all switchgear subject to NEC requirements in metal enclosed is metal enclosed. Switchgears rated 1,000 volts or less may be identified as low voltage power switch circuit breaker switchgear. Switchgear rated over 1,000 volts may be identified as metal enclosed switchgear or metal clad switchgear. Switchgear is available in non-arc resistant and arc resistant construction. So, like I said, that arc resistance, and I guess that's what I was trying to get out, that is accessory devices or type of equipment that's associated with the switchgear. So that is all switchgear. Now, it might break out and you can label it other names, but in reality, it all is encompassed over the term switchgear, and that's what we were trying to say. So that definition encompasses all three of those type of switchgear. So, let's look at the overall changes. The definition of metal enclosed power switchgear, again, was revised to just be switchgear. It addresses all switchgear. The information note applies to let you know that the term switchgear includes metal enclosed low power circuit breaker switchgear, metal clad switchgear, and metal enclosed interrupter switchgear and all that. All of that is still considered switchgear when it referenced in the NEC. For example, on the 408 where it talks about switchgear. All of those would be inclusive and had to meet the requirements of that article is what we're trying to say. All right, let's move on. Okay, let's talk about the available fault current. Now, this comes up an awful lot, and a lot of people think that available fault current markings and the short circuit current ratings of equipment get confused with NFPA 70E for the different type of working zones that you would work in, hazardous zones. Safety in the workplace versus the requirements for available fault current on the equipment itself. And so there's a lot of confusion in that. So when we're dealing with non-dwelling unit service equipment that is required to be field marked with the amount of available fault current when installed or modified. Now the only change really here, there was a big change in 2011 which required you to have to put this date that you did the testing or the calculation. It forced you to have to put the available fault current at the main disconnect area. And it forced you to make sure that your short circuit current ratings or your RMS SYM actual symmetrical fault current of say it's 65,000 amps on a piece of equipment. You have to make sure that your available fault current doesn't exceed that 65,000 so it doesn't damage that equipment. It can maintain its function. So you have to post that on the actual equipment. Well, in the 2014, they added an informational note, and that informational note said the available fault current markings that are required by 110.24a are related to required short circuit current ratings of equipment. Doesn't have anything to do with the distance of working or unsafe work zones when you're dealing with NFPA 70E. That's a totally different thing. Okay, so they didn't want to confuse the two. Totally separate calculation that gets done for 70E versus what's in NEC. The available fault current required in 110.24a is about the equipment and the circuit breaker and the terminations and the equipment itself, the enclosure. All of its rating, its SSCR ratings and AIR ratings of the overcurrent devices and the switches and all that. So that's what it deals with. It's totally different. So we wanted to make sure that they made it real clear that it has nothing to do with the 70E when you're looking at these requirements on this equipment. And so that was really the only change. In 2011, that was significant with the labeling requirements and what have you. But now I think people got confused and thought that this had something to do with 70E, and it does not. So that's the informational note that kind of gives you guidance in one direction. or not. Now, when we talked about that new change early on, a wide change was the 110.25, which was the lockable disconnection means, and the new 110.25 was added to provide a one location source for that lockable disconnection mean rule, so that you didn't have to try to encompass it in every single individual article that or section that referenced it. You could send it back to 110.25. Now, there were 46 companion proposals that tried to move the lockable disconnect means to a new 110.25. So it wasn't just one thing that did this. There wasn't just one thing that happened at the code making panel. There were plenty of proposals in order to make this happen. And basically, this locking out, this lockable disconnection means helps to facilitate the proper operation also of a lockout tagout procedure. And also anywhere in the code that that requires that locking component, like we said, for appliances or motors or what have you. So that's a critical aspect, and it really needed one place in order to place this direction, and that's what it did. And of course, we know about the exception, which talks about the attachment plug. When it is served as a disconnect, without the lock on it, doesn't have to stay in place, because it wouldn't. It would probably just fall right off. So that's the change in that. Okay, so let's move on to Article 200. So there was a change, a significant change. A new subsection was added, 200.4b, with dealing with the neutral conductors in multiple circuits. Now, a new provision was added requiring you to group common neutrals with the actual ungrounded conductors within the same enclosure for that circuit. So you group them together in the same enclosure. It's really easy to identify ungrounded or hot conductors, but since the neutral conductors terminate on a common bus, it really gets hard to try to trace them and follow them. And you want to make sure with a multi-wire, multi-circuits where they might be sharing a neutral, that you're able to identify them properly. So a new provision was added requiring the common neutral conductors for multiple circuits with its associated ungrounded conductors when contained in the same enclosure. So if they're all in the same enclosure, then you're going to have to identify them out so that the ungrounded conductors are connected with its associated grounded or its associated neutral conductor. New exceptions were added to relax this requirement for branch and feeder circuits when they actually were looped conductors or conductors for branch circuits that simply pass through the box or conduit body. In other words, they just simply pass through. Then you add an exception there, and let's read that exception. It says, where the requirements for grouping or identifying shall not apply if the branch circuit or feeder conductors enter from a cable or a raceway unique to the circuit that makes the grouping obvious. So they have to come in through one raceway, and it's obvious that it comes in from one raceway, and it's obvious, and you don't need to worry about any grouping. Now that's not really different than we did before, because if you've got, let's say you have 4 hots and 2 neutrals coming in, then you're going to have to take that one neutral that groups with that one set of hot conductors that share that neutral, and then same for the other on those multi-circuits applications like that. Then you'll have to identify them in order to be able to do that on those common neutral applications. But if I only had one raceway coming in or cable which had the 2 hots and 1 neutral, then it's no need for me to do anything, obviously, because it's real obvious that neutral goes with those circuits. So that's what it's saying. Now, the other exception is one I'm talking about. It says requirements for grouping or identifying shall not apply where branch circuit conductors pass through a box or conduit body without a loop as described in 314.16b1 or without a splicer termination. Again, that says clearly that applies to branch circuit applications, not necessarily feeder conductors that do that. So even if it's a bunch of feeders that come through and it's not obvious, you got to group them and identify them. But for branch circuits, it shall not apply to those branch circuits that pass through a box or conduit body. Okay, so keep that in mind. Let's see here. Yeah, you know what? That's all we're going to do for today's class. Because we've already gone over an hour, and so we just want to give you some, aspects of the code to take away at this point. So that's probably as far as we're going to go. If I had to do one more, yeah, let's do one more. Let's do 200.6A3, means of identifying the grounded conductor. Now, the means of identifying a grounded conductor in the 2014 code, it permitted you to have 3 continuous white stripes, on a conductor, except for green. You couldn't do it on green, but any other color other than green, I could have. It could be white, it could be gray, or it could be any color other than green with 3 continuous white stripes. Well, they added or gray, so I can have 3 continuous gray stripes as well on 6 AWG and smaller size. These are 6 and smaller. Then I could re-identify it that way. Or that's not re-identified. That's what I could do as far as the markings. And as a manufacturer of wire, we could either produce gray or white or any other color other than green with 3 continuous white stripes or 3 continuous gray stripes. That would be our choice. Okay. Now, the gray coloring for a grounded conductor is frequently used in a 270-480 circuit, especially when it comes together in some types of equipment where you have to distinguish, say, a 12208 with a white grounded conductor or a white neutral from maybe a 277-480 where it might be a grounded conductor, not necessarily a neutral. But typically, we might use a gray for that. So, have to keep those things in mind. The white or gray stripes will offer more choices for the installer because just recently, and when I say recently, in the last few years, the ability to apply the gray color onto these colors and make it distinguishable has gotten a lot better in the technology and be able to apply those type of colors. So that's where you get the allowance now for the gray. They always allowed the gray. A few cycles back, they added the gray to be able to mark it. But it gives you more versatility for identifying the grounded conductor, so you get more options. And again, this change is no different. It took place in 200.6B2, 200.6E, 200.7, 200.7A2, 200.7C, 200.7C1, 200.7C2. In other words, all these areas, they added that or gray allowance for the striping as well. Okay. All right, everybody, that's all we're going to do today. Hopefully I didn't confuse you. I tried to cover some of the aspects of it. Didn't want to go too deep with it. Hopefully that's helped you understand a few of the changes. So again, that's part 1 of analysis of the 2014 NEC. Hope you enjoyed it. If you have any questions, feel free to email us at info@masterthenec.com. We're more than happy to answer your questions. And until next time, God bless.